All right, so this is the last presentation of Unit 1. With this one, we're mainly going to look at seasons and weather and things that affect climate and stuff like that, but there's a lot of key terms in here that you're going to need to know. Several things I'm going to talk about in the upcoming units, so you definitely want to make note of a lot of things I'll be going over, and I'll really make sure to highlight the most important stuff that will come up several times. All right, so the first question that we're going to answer really is looking at the kind of weather we have to adapt to, of course, what creates the weather, why do we have seasons and things like that. So obviously here in Texas, we have hot weather in the summer, so we've created air conditioning to be able to adapt to it. Of course, swimming pools, things of that sort. In drier conditions, sometimes we can go through droughts, and so we have lakes and things like that to collect water. To make sure we have something to drink, and of course can make it through the drier times. And then we'll get into, of course, why we have seasons. So let's do that real quick. So seasons and sunlight. You do need to know the difference between a solstice and an equinox. All right, so like in September, which is coming up, the equinox means that the sunlight is directly over the equator. So in September and March, on the equinox, the sunlight is directly hitting the equator. So at that time, in September here, it's fall. Of course, in the southern hemisphere, it's spring. And then you get into the solstice, and this is where the sun is either at its northernmost or southernmost point as far as where the direct sunlight is going. So on December 21st, that's the winter solstice for the northern hemisphere, summer solstice for the southern hemisphere. At this point, direct rays are going at the Tropic of Capricorn. So those tropics, Tropic of Capricorn and the Tropic of Cancer, are the northern and southernmost points the sunlight hits. So when it's winter here, the sunlight is directly hitting the Tropic of Capricorn in the southern hemisphere. And then in June, when it's summer here, the sunlight is hitting the Tropic of Cancer. And that's the northernmost point the direct sunlight goes. And so sunlight is always hitting somewhere in the tropics directly in between Capricorn and Cancer, with the equator in the middle. So that's so solstice is when it's hitting one of the extreme points. The equinox is when it's hitting the equator, and both hemispheres are getting equal amount of day and night. So here again, you can see, so when it's winter here, sunlight's hitting Tropic of Capricorn, whereas we're up here, and so we get less daylight and colder weather. All right, so now you need to know the difference between weather and climate. These key terms you'll see a lot. So weather is condition of the atmosphere at a particular place and time. So what that means is, if I asked you, what is it like outside right now? It's about 8:30 in the morning. So this current time, it's 78 degrees. It's sunny. That's what it is right now. Of course, later today, it's going to be a little bit different. So weather is what it's like at a particular place at a particular time. Whereas in climate is the weather conditions at a particular location over a long period of time. So in this case, we'd look at what is the average temperature in August in Flower Mound. And you're looking at years of data, over 100 years of data. That you're going to say, well, the average high this time of year is 95 degrees. And so about a week and a half ago, when it was cooler here, at least during August, it was cooler here, so that was below average. So when you hear weathermen talking about being below average or above average, they're comparing that to what the overall average is. They're talking about the climate of the region. So weather is what it's like right now, particular place, particular time. Climate is conditions in a particular location, but over a long period of time, looking at averages. Sea land breezes, we're not really going to do anything with that, so we'll move on. Hydrologic cycle, just remember again the water cycle, we talked about that yesterday. Then convectional precipitation, you need to know the different types of precipitation we'll see. So convectional precipitation occurs in the tropics. So generally what happens almost every day is it heats up throughout the day, and then around 3 or 4 in the afternoon, clouds build up, and then you see rain. It's usually not like strong thunderstorms, it's just a nice kind of soaking rain that comes down. So that's convectional precipitation. You also see that in southern Florida too, where it'll just be like a normal nice day, and then all of a sudden there's a storm. Orographic precipitation is in mountainous areas. Same things if you've been up in the Rockies, it can be sunny and look nice, then all of a sudden a storm just pops up out of nowhere. So that's orographic precipitation. And then with that, we can see what's called the rain shadow effect, which you need to know what this means, this term here, rain shadow. So like in California, for example, you have the ocean, you have moist air coming off the ocean onto the land. And then, of course, that moisture rises, and then you get thunderstorms and rain, and it rains on this side of the mountain. This is the windward side of the mountain, so the side where the wind hits. And then it rains on this side, so it's nice, lush, and green. But that moisture can't quite make it over the mountain range. And so on the other side of the mountain range, you have the leeward side, which is dry. And this is the rain shadow. So basically, the rain all falls on this side of the mountain range. On the other side of the mountain range, you're going to see a desert. So that's why you can see deserts very close to the ocean, because if you have a mountain range in between them, that's going to block that moisture from being able to make it over to that area. So here's a kind of a better idea looking at it here. You can see the Bay Area of San Francisco. So the wind comes across from the ocean onto the land, bringing that moisture, so it rains near the coast. Nice, beautiful temperatures in San Francisco. The Central Valley gets a little bit drier, like around where Sacramento is. Then you cross the Sierra Nevadas, and then after that you're into Nevada and the Great Basin, and it's just desert. So the moisture can't make it over all these mountains. It's gonna, fall on here, and so that's why you can be in Lake Tahoe. It's beautiful, snow everywhere, and drive a little bit out of that, you're smack dab in the middle of the nasty desert in Reno. All right, and then frontal precipitation. This is what we see here. This is in the mid-latitude areas, which is where we are. Frontal precipitation is like a cold front coming down, which we see from Canada and the Rockies. Will come across and it hits the other air mass, which the other air mass that's always around us is the moist air from the Gulf of Mexico. So those two air masses meet and then creates thunderstorms. All right, let's move into climate and climate regions. All right, so you need to know what factors affect climate. So all these factors here affect climate. You need to know how. So air currents, ocean currents, latitude, elevation, landforms, and continentality. So air currents, for example. So I'll take the westerlies as an example, and you'll notice too that the names for the different wind patterns, they base it off of from where the wind is originating from. So the westerlies actually blow in a northeasterly direction predominantly, but they start in the southwest and go that direction. So like for example in Europe, the westerlies carry nice, warm, moist air across the Americas, across the Atlantic, all the way to Europe, and warms Europe up. So even though Europe is very far north, it can have a warmer climate, especially along the coastline, like in Spain and also in England and things like that, because of the westerlies. And so that helps warm that area up. So that's an example of how air currents can affect the climate. And here you can see just more details of the different types of winds and things like that, but we'll move on. Ocean currents, of course, are large circular systems in the ocean. Warm water heads towards the poles, and then as it cools off, it comes back down towards the equator. So basically like a conveyor belt of cold and warm water. And if you live near the coast, this is going to have a dramatic effect on the temperatures there. So for example, going back to California again, you get cold currents coming down from Alaska down along the coast of California, and that's what keeps San Diego, for example, which is about the same latitude as we are, but it's a lot cooler in San Diego because of this cool current coming in. And again, once you get away from the ocean and you drive across the mountain ranges into the deserts in California there, it could be 110 degrees 50 miles away from San Diego, but in San Diego it's 78 degrees because of that ocean current. And then here on this side we have a warm current. The Gulf of Mexico has a warm ocean current, and so it's going to create a warmer area where we are. All right, then latitudes. Obviously, the further north you are from the northern hemisphere, the colder it's going to be. We break down latitudes into 3 zones. You do need to know these. So low latitude or tropical latitude. So that's anything in between the equator and the Tropic of Cancer. If you're in the southern hemisphere, between the equator and Tropic of Capricorn. The middle or temperate zone, this is where we are, and this is where most of human population is. So this is everything that's in between the tropics and the polar regions. Then high latitude is your polar area. So most of human population is going to be in the mid-latitude area. So again, tropical low is near the equator, in between Tropic of Cancer and Capricorn. It's hot all year. You don't see any seasons. It's wet and dry season, and that's about it. But they don't have the 4 seasons like we do. High latitude, your polar areas, it's cold pretty much all year. And then mid-latitude is where we are, and this is where you see the greatest variation of temperature. It's going to be in the mid-latitude region. All right, elevation. So as you go up in elevation, it gets colder, of course. So about every 1,000 feet you go up, temperature drops 3 to 5 degrees. And so this is why you could be in places like Mexico City, which obviously is a lot further south than we are, but it's high in elevation. So the average high temperature in Mexico City can be in the mid to upper 70s. They actually have amazing weather. So elevation plays a huge role as well. And then landforms basically just go back to what we talked about with the rain shadow effect, how mountains and stuff can block moisture coming over as well. And then continentality. This one we're going to talk about a lot throughout the year, and a lot of students miss this. So continentality is the distance from the moderating effects of the ocean. Basically what that means is the more interior you live in the continent, the less the ocean is going to be able to regulate that climate. And so you're going to see more extremes between summer and winter months. So give you an example. Here where we are, we still get the effects of the ocean from where we live. But if you go up north to like Nebraska, you're pretty far from any ocean at that point. And there you're going to see greater extremes. It can be real hot during the summer, but it can also get really cold during the winter. Of course, the greatest example of that, though, is Siberia. So right smack dab in the middle of Russia, you're far away from any ocean, so it can get maybe to 50 or 60 degrees in the summer, maybe even 70 if you're lucky. But in the winter, it can get down to negative 60, negative 70 during the winter. And so because you don't have the ocean there to kind of moderate the climate, it's another reason why human populations tend to live closer to the ocean. All right, El Nino and La Nina. These play a huge impact on the climate as a whole throughout the world and weather conditions. All right, so El Nino is basically a natural change in climate. It occurs every 2 to 7 years, and what it is a shift in the ocean temperature, surface temperature in the Pacific Ocean along the coast of South America, so along the west coast of South America. So during El Nino years, you're going to see it be dry in Australia and most of Asia. You're going to see drought and really hot temperatures, while here in the Americas, you're going to see generally cooler temperatures and a lot more rain. So one of the reasons why we saw more rain this past year and just got dumped on was because of El Nino. We had one of the strongest El Ninos in recorded history. And then when it's opposite of that, when the ocean is cooler than normal, then it's called La Nina. And basically the opposite happens. It becomes hotter and drier here in the Americas, and it rains more in Australia and Asia. So basically it affects the climate and weather conditions throughout the Pacific region. So here's a photo of it. So El Nino is this entire area here. So all this water when it's at a higher temperature than normal. So this changes the weather all throughout this half of the world. All right, moving on to soils and vegetation. So first off, an ecosystem, you should already know this, is an interdependent community of plants and animals. So you could look at, like Lake Louisville and the ecosystem that's there. But then on the bigger side of it, you have biomes. And so a biome is an ecosystem of a region, so looking at entire region. So this is divided into like forest, grassland, desert, and tundra. So for example, we live in a grassland, and the grassland extends all the way up into Saskatchewan in Canada. And so we're going to share a lot of similarities throughout this entire region. They may have some different animals up there than we do here, but generally speaking, we're going to share a lot of the same types of things. And then getting into forest, you do need to know the two different types of trees. So you have broadleaf trees or deciduous, which is the word you'll see like on tests and stuff. Those are the type of trees we see like in the rainforest. It's also the type of trees we have here. So it's ones that lose their leaves in the winter. And then type 2 is needle-leaf trees or coniferous, which is the word you'll see on any test. And those are your evergreen trees. You mainly see those up in the mountains, like in the Rockies. So deciduous and coniferous are the two you need to know. And then moving into grasslands. So we have grasslands all over the world, some huge ones. We actually live in one of the biggest ones in the world. But generally, these regions are flat, as you can see, because you live in one. You'll see some trees, especially if there's like a creek or something nearby. There'll be trees along those areas. Different words you may see for a grassland would be plains or savannas or prairies. In South America, they have a couple of different ones, the cerrados, llanos, and pampas. And then Russia, you see the steppes, but it's all the same thing. They're all grasslands, all look similar. We just use different words for in accordance basically with where they are. So like, for example, the llanos is in Venezuela, the pampas is in Argentina, the steppes is in Russia and throughout Central Asia. So basically, we just know where it is based on the name. Of course, savanna is in Africa, Eastern Africa. All right, so that's it for Unit 1. Just be sure for the test and the quiz that you review over your notes. especially for the test. Watch the review I put on Google Classroom for the test. Review over your notes, review over your vocab, and you should be good. And also, you're free to come in for tutoring as well. Just talk to me and let me know if you're going to come in. All right, good luck.